Hello, now I'm going to demonstrate a titration lab. Titration is a lab that is used when you're trying to determine the concentration of an unknown solution. Right now we have an unknown concentration of NaOH, or sodium hydroxide, and a known concentration of hydrochloric acid. This is a base which we don't know the concentration of, and that is what we're going to do today. To start your lab, you must first prime your burettes with the solutions that are going to be put in them. So for this burette, we're going to pour just a small amount of hydrochloric acid to get the walls of the burette completely coated with the acid. And we're going to allow this to drain all the way through. We'll do one more. Now that the walls of this burette are completely primed, we'll close the stopcock by turning the bottom handle. Now no more liquid can flow through the pinhole. And we're going to fill the burette all the way up to the 0 millimeter line. And we are using 50 milliliter burettes for this experiment. Okay, now that our hydrochloric acid burette is ready, we must now repeat that same process, getting rid of this hydrochloric acid, with sodium hydroxide of unknown concentration. So open your stopcock and pour just a small amount through the funnel. That'll get the walls of your burette completely primed with the substance. Now once you have done that, you can do the same, closing your stopcock and fill it up to the top. Now that we have our burettes completely primed and filled up to the 0 milliliter mark with our substances, we now move on to the titration process. To start, open your stopcock of your unknown basic solution and allow about 10 milliliters to flow into this 125 milliliter Erlenmeyer flask. It'll take just a few seconds because the stream is pretty tight. We have about 10 milliliters of the NaOH in the flask. We'll add just a small amount of distilled water to add to the volume of the solution. Swirl it around a little bit. Now that we have our NaOH in our flask, we'll now add a few drops of phenolphthalein indicator solution to the mixture. This is going to be the key part in telling us what our concentration is. One, 2, 3 drops will be good. Now gently swirl your flask around until it's completely mixed in, and move your flask under your hydrochloric acid burette. Now the goal here is to find the fine line between pink solution and clear solution that makes the balance between acid and base perfectly equal. So what we're going to do, as you can see, there's still pink in the flask, is going to add hydrochloric acid, just 1 or 2 drops at a time. And then we're going to swirl it around a little bit. As you can see, it's pretty clear, but there's still a faint tint of pink in there. So I'm going to put a few more drops. Oh, maybe use a little bit too much, but that'll be okay because you can always add more of the unknown solution. So now our solution is completely clear. But we don't really know where the fine line is right now, so we go back to our NaOH burette and add just a little bit of that. Swirl it around. As you can see, it's still not pink. When the concentration of this becomes greater than the concentration of the hydrochloric acid, it'll turn pink again, and that's what we're looking for. Sometimes it helps if you use a sheet of white paper underneath so you can tell if there's any pink in there. We still have a little ways to go. Now that our pink color has returned, thanks to our unknown concentration of base, we'll put it back into our acid for a final measurement. And the goal is to make the pink color barely disappear. Swirl your flask around. As you can see, there is no pink left in the flask. Your next step is to read the volumes of both your acid and your unknown base, and then use the appropriate equations to determine the concentration of your unknown concentration of your basic solution. That is a titration.